So far we have seen how to implement the remove method, the put method and the get method, and basically all of these methods relies heavily on the hash function. If the hash function is perfect, the get method is going to be order 1 constant time complexity running time. The put method is going to have order 1 running time. It's going to be very fast because there's not going to be collisions. We just have to check the updates. And the remove is going to be very fast, we just have to consider the clusters. But if the hash function is perfect, then it's going to make sure that there will be several clusters, so we don't have to make several shifts. So approximately is going to be order 1 time complexity. This is why we have to make sure that the hash function is going to be approximately perfect. So we just have to implement this resize method, and it's going to be order and running time at the best case. So this is basically the bottleneck. It's going to get a capacity or new capacity, and we just have to create and instantiate a new hash table. So a hash table with the key and the value. Okay, it's going to be the new table with the camel casing, sorry. So a new hash table, and then we just have to iterate through basically the capacity. So 0 is less than the old capacity, so this is the capacity of the actual table plus I. And basically we just have to check that if the keys at the given I index is not equal to a null, it means that there's an item. We have to insert, so the new table dot put the keys at the given index, so the I, and the values at the given index I. So what does it mean? That we have to rehash the table entries because the hash function relies heavily on the capacity or the size. As you can see, the hash function is going to generate the indices of the array according to the capacity, so the actual size of the array. So if we resize the table, of course the size of the table has changed, and if the size of the table has changed, it means that the same hash function is going to return with a different integer for the same key, because the capacity has been changed. So that's why we have to rehash new table, put again all the items where the keys are not equal to null. Of course, we don't have to hash the null items. By the way, if we put null values here, it's going to return without any problem, so we don't have to check it anyways. It's going to be straightforward. And then we have to update, so the keys are equal to the new table, sorry for that, new table dot, okay, I'm going to generate getters and setters for the key, value, and so on. So generate getters and setters for the capacity, keys, values, number of items. Ctrl-Shift-F to auto format. New table dot get keys. Then the values are equal to the new table dot get values. The capacity is equal to the new table dot get capacity. Of course, sorry for that, we have to use this constructor, so this constructor should be used. So that's why in the resize method we have to specify, it's very important that in the constructor we specify the new capacity. And basically that's all about the resize method. It's quite straightforward. We have to create a new table and we have to rehash all the items. Why? Because the hash function relies heavily on the capacity, so the actual size of the table. And the resize method is going to change the size of the table, so we have to rehash them. That's why this order and running time. So what's the conclusion? We have to make sure we minimize the number of resize operations. How are we able to optimize it? We can decide, as you can see here, for example, we have to specify a good load balance in the sense that what's going to be the number of items when we have to resize, and what's going to be this when we shrink the size of the table. And basically, researchers are working on these kinds of problems, that what's the optimal solution. It is quite an optimal one. We just have to halve the size of the table when the capacity is 33%. So it is quite optimal, this implementation, that whenever the 33% of the table is full, then we have to resize and halve the size of the table. And whenever the 75% of the table is full, then we have to double the capacity, so double the size of the table. So that's all about the resize method. Thanks for watching.